it's not a solved problem, and the current solutions are either centralized or not scaled. If you used public key before, you must have heard of one of the two methods. The first one is PKI, which stands for Public Key Infrastructure. In this method, there are centralized third-party certificate authorities who certify your public key to your email address. So you rely on their credibility and their ability to verify. If you use PGP, then you probably have key signing party to distribute your public keys. So we're coming up with the first blockchain-based solution. And this solution has the following features. It's distributed, it's extremely easy to use, and we have built-in verification mechanism which ensures your public key bound to your email address. No one else can present your public key falsely. Also, our solution is very scalable. It has been approved by the application of blockchains. So this slide highlights the simple user interface. So as a user, when you click on the top button, which generates your public key and the private key, it automatically pushes your public key into the blockchain and published to the world. And the bottom of the screen allows you to search the public key of other people by typing the email address. And a lot of things happens in the backend, but you don't have to worry about it. What's going on in the backend? So the backend has two major components. The front end, which is a Chrome extension working with Gmail, and the backend is the blockchain itself. So we use a verification mechanism to verify the binding of public key and email address with a mechanism similar to three-way handshaking. The first, when a user publishes his public key into the blockchain, which says this public key belongs to this email address. Second, the blockchain randomly selects n nodes, which is roughly 30. Each node sends a challenge to that email address, which can be only solved by the corresponding private key. Third, the user solves the challenge and sends the response back so that the challenge node can verify its answer. If half of the n nodes correctly verify the challenge, then he's admitted into the chain, into the network, and his public key is securely established and published to the world. So this is our team who implemented this work. So we're going to see which part.
Hi, I'm Alan. I'm handling the Web3.js, which handling the bridge between the front end and back end.
I'm Hack. I built this Chrome plugin like the mask, and also handling backend Gmail checking and talk to Web3 and blockchain.
I'm Jeremy. I wrote the Solidity code for interacting with the Ethereum network.
I'm Solomon. I'm actually just a volunteer who is watching what everybody else does and learning how hackathons work.
Thank you. Great presentation. Thank you. Big round of applause.
Okay, so first I want to appreciate you're very clear about the problem definition. The public key is a genuine problem. What I fail to understand a little bit, I need your help over here, is you talked about the 30 nodes, right? The energy transmission of the 30 nodes for the email confirmation. What makes you very different? Because this idea can be copied, and best ideas are always copied, right? So give me a little bit of deeper dive.
I agree, that's a good way to verify. But current mechanism don't use it for reason I don't understand. If I distribute a key server, the first thing I would like to do is to verify the public key is associated with the email address. But for reasons I don't know why the current key servers don't do this.
So you mentioned about the email verification, right? So is that part decentralized?
Yes.
So how?
So we maintain a global structure which basically says how many nodes in the network, and we randomly select. So random, this is key to guarantee security. So we randomly select n nodes, which is roughly 30, because we choose 30 because there's a theorem in statistics called big number theory. So if your random sample size is to 30, then no matter how much you add, the value is minimum.
Okay, so you mean that those nodes will send email to that email address to verify the email and the public key pair?
Yes, that's correct.
How do you plan to get users for your system?
There's a very easy bootstrap process, because worldwide, although PGP are really difficult to use, there are more than tens of millions of people who struggle with PGP configuration and struggle with how to distribute key. They're using PGP. So if this system makes this technical barrier so low that the user doesn't need to know any cryptography knowledge in order to use the system, I don't think it's hard to attract them.
Okay, so I have one question. So still about the email verification. So you mentioned about the node, right? So trusted node. So which random algorithm you are using to make sure those node connections are really fully randomized?
Currently, we decided to use the random SKU number and mod it with 30. So that's the current solution.
Okay, you have tried Nebulous. We have some kind of verifiable random function which provides fully verified random function on chain. Yeah, that would be good for your project.
That's really nice.
All right, that's wonderful. All right, big round of applause.